Hello guys, my name is Rohit Asalkar and I am giving a seminar on GSM Interfacing. So, what is GSM? GSM stands for Global System for Mobile. It is a second generation cellular standard developed to cater voice services and data delivery using digital modulation. So, in order to communicate, we need a module, that is GSM module. Here I am interfacing SIM900A module with the 8051 microcontroller in order to transmit data. So the question arises, what kinds of modules present in the market? Right now there are two types of modules, GSM modules present in the market, that are SIM300 and SIM900. So the differences between these are quite few. SIM300 is a tri-band module, whereas SIM900 is quad-band module. SIM300 operates at 900, 1800 and 1900 MHz, whereas SIM900 can operate at 850, 900, 1800 and 1900 MHz frequency. But SIM900A works only in the India. Basically, SIM900 is most preferable module nowadays because it is advanced version of SIM300 and the bugs of the SIM300 has been overcome in SIM900. 80 commands used for call and SMS is same for the both modules, so we did not want to worry about the new 80 commands. So we know 8051 controller is 40-pin DIP dual input package controller. Now we are focusing on two pins of the controller, that is pin number 10 receiver pin and pin number 11 transmitter pin. So now let's have a look at the features of the 8051. It has a ROM of 4 kilobytes. We know ROM is read-only memory. Means we can save program of 4 kilobyte size. It has a RAM of 128 bytes. It has two timers. Both timers are 8 bits. It has 32 pins. It has 4 ports, general input-output ports of each of 8 bit. It has 1 serial port and 6 interrupt sources. Whenever the concept comes serial communication, the term comes as baud rate. So basically baud rate is the number of symbols transferred per second. If we want to have different baud rates, we have to assign different value to the TH1 timer register. So standardly 9600 is the baud rate, which is means used by many controllers and serial communication. So in order to have different baud rates, we have to assign different values. For example, 9600 we have to load -3 decimal value to the TH1 register. Similarly, FD in hex. So SBUF register. It is 8-bit register used for serial communication. To transfer data via transmitter line, it must be placed into SBUF register. Whereas SBUF holds a byte of data when it is received by 8051's receiver line. Means all the communication takes place through this SBUF register only, and it is of 8-bit. So in order to communicate with GSM and 8051, there are 80 commands. So here is the list of 80 commands. First one is 80. 80 stands for attention. Means if we give 80 command, it will respond as OK. Then second is 80E 0. 80E 0 is used to reduce the echo. Then next one is 80 plus CMGF is equal to 1. This is to set module in the text mode, as we are interfacing GSM module with 8051 in order to send a text message. So we require one mobile number on which we will send SMS. So 80 plus CMGS is equal to plus 91 and mobile number is the next command. Here we have to write a number to which we want to send SMS. Then the last command is control Z. It indicates the termination of the message. So to interface SIM900A module to 8051, there are 3 pins to be considered. First is transmitter pin of the GSM is to be connected to the receiver pin of the 8051. Receiver pin of the GSM is to be connected to the transmitted pin of the 805. And the most important thing is that ground of the both modules should be the same. Let's have a look to the C code of the sending message. So this ATE0, AT, CMGS, CMGF, these are the arrays used to store the commands of the GSM, whereas message indicates the message we are going to send to this number. So the message quoted that welcome to the world of robotics.
Here is the main function of the code in which GSM has been called. In GSM function, we have calling initialization and send SMS. In this initialization, we are assigning the values to the different register. First one is SCON register, in which we are assigning 0x50 value. This will set mode 1 8-bit UART and it enables receiver. The second one is T mode, in which we are loading 0x20. It is T mode register. So it will set timer 1 mode 2, which is 8-bit. Then we are loading FD to the TH1 register in order to set 9600 baud rate. Then we are activating timer 1. So after this, we are sending commands one by one, that are ATE0, ATE, then AT CMGS, CMGS, and then message. So let's have a look at the simulation. So in simulation file, we will come to know that how these commands actually sends. So when we are going to run the simulation, the window virtual terminal will show the commands sent by the controller. So first one is to minimize the echo, then 80 for attention. This is in text mode. This is the number to which we are going to send the SMS, and finally the SMS will be sent by the GSM. Welcome to the world of robotics. That's all. Thank you.